What is up, everybody? Today is March 13th, 2025. It's going to be another day of Type Racer. Let's go ahead and get ourselves into it, and let's go. Not too bad, not too bad. 105, 105. Okay, get to the problem of the day. I think I've done this problem before. Or not. 2226. Maximum candies allocated to K children. You are given a zero-indexed integer array candies. Alright. Each element in the array denotes a pile of candies of size candies I. So each element. So 5 candies, 8 candies. Okay. You can divide each pile into any number of subpiles, but you cannot merge two piles. Okay. You can divide, but not merge. You're also given an integer k. You should allocate piles of candies to k children such that each child gets the same number of candies. Okay, each child can be allocated candies from only one pile of candies, and some piles of candies may go unused. So if you have 3, okay, so if we have a minimum value, say 5, can't merge. Sorry. Yawning. We want the maximum number of candies they can get. you have 3, but you can't merge them, right? So you're looking for the k largest, the minimum of the k largest candies. Wait, no. We want the k largest. If you find something bigger than the smallest value, oh wait, no, we could just do, yeah, because we want to get rid of the smallest values, right? Oops. Why is k long? 10 to the 12. Wait, this might not work. Only 7 candies. Subpiles. Maybe priority queue is not going to work. Okay, let me think. 5a6. We know 5 only because k is equal to 3. But what if k was equal to 2? The max would be 6, right? Okay, but what if the k was equal to 4? You can't merge piles, which means whatever the excess is, so the best you can do is 4. So if I say I had 4, the answer would be 4, right? Oh. 4. Yeah. And how we got 4 was we took half of this, and you can't add another one. So whatever value we find, k equals 3. K equals 3. We have k equals 11. How would that work? You would need at least 1 candy per child. And you can separate them all individually, so it's fine. Okay. Take 4, split it in half. That's the next child. Right? So this divided by 2. Then you take the next maximum and divide it by 2. And take the next maximum and divide it by 2. And you do this k number of times over the free children. So you have 3 here. You divide a value by half. Like this would need to be divided by half 9 times. But 10 to the 12, how can we do that better? You can divide the entire thing in half if it's doubled. Because they're all going to be divided by half and the same order is going to apply. Right? So there could be a modded value in there. Like the number of halves that we need to divide by. So, okay, so we have 2 values. And we can't divide 2 values. If you get a 1, you can't divide 1 by a candy. But we're always doing it by the maximum values, right? So what is the maximum half division? Of the greatest value. No, that wouldn't work either, would it? Because say if you divide 5 in half, or yet better yet, if we take this first one, let's say whoops. Close. What if k was equal to 10 for these 3, right? if we divide 3 of these in half 3 times, and then we only need to divide the largest value in half once. Yeah, because you go from the largest. So, okay. K divided by candies.size. All right. And then rest equals K mod candies.size. So the remainder, okay, int div. So 3 divided by 3 is equal to 1. We divide them all by 1 and take the minimum of the third one. What happens if the pile of candies is greater than K? Oh, if it's greater than K, we can give it the whatever kth value is. So if K is less than or equal to candy.size, so there's 3 piles and 3, we just take the third value, which means we need to sort them first. Sort candies.rn, candies.rn. Okay, we can just return candies of K minus 1. Right? Now, if there is less of them, then we want to divide this by this. Candies has to at least be 1, right? So if I did something like int div K divided by candies.size, int remainder candies.size, then we can do something like, okay, so it's already been sorted, and we have our divisor, so it's like the weight. And our remainder. So basically we want to so if we have 2, 5, 8, or 2, I'm sorry, 8, 6, our remainder 3 would be 1, and our div would be 3. So we're dividing all the values by 3. Okay, what happens if they're not? Oh, wait, no. 3, I think, is shifted over. Or no, divided by 2 3 times, right? So you take half, then half, then half. So, and there's a remainder of 1. I don't think this is going to work. I think this is I need a test case that's going to work. Hold on. 10. Oh. Just want to test the test case, yo. Okay. X output expected 1. Right. Because this would be divided down by 3 times. So half would be 4, half would be 2. Oh, but you can only put it in one pile, right? So this would be half is 4 and 4. Which doubles the amount of children. We need, if we have 10 children, 10 divided by 3. Uh, 3 children for 5 candies would be what? Would be a minimum of at least 1. The remainder doesn't matter, does it? All we need to do then is take 10 hold on. 3 3 divided by 5 is 1. What would happen if 5 was 6? It would be 2. 3 divided by this is 2. You have 3, 3, 3, and then 1 extra. So we would add 4. So it's the div plus the remainder until there's no more remainder from the greatest value. So this would be 2, 3, and 3. And it's going to be spread out among all the candies. And basically we take the smallest value. Or so this 4 divided by this value. Candies I. No. You have 5 candies. And you have a pile for... You want to take the 5 max values. So is this just K? Wait. If K... No. That's why we're using mod. Yeah, so this, no matter what, this is going to be larger, right? Which means we kind of use every pile. This makes 2 5s. 5, 5, 4, 3. No, this isn't going to work either. Yeah, this is kind of a flawed idea. Because I'm assuming that I'm going to want to divide them all evenly. Dividing always makes the values smaller. Okay, let's do this. Bn login k can be an absurdly high number. 10 to the 12. This divided by 2 is greater than the smallest value u, I guess. Let's look at the hints. I'm not actually sure. Oop. Oh my goodness. It's a binary search problem. This is a binary search like Coco's, isn't it? If I said k equals 5, then we're looking for a valid split. If we have 3, okay, even if we have a valid, how would we check if it's valid? 3, 3, 3, 3. Is only 4. Wait, how do you get 3? Oh, this is divisible by 3. This makes 3 piles of 3s. So 3, 4, 3, 3, 3. Gotcha. Okay. I know how to solve this problem now. Oh my goodness, topics just gave it away. Why could I not see that? Okay, so int left r equals 10 to the 12. Wait, so we have k children. So the largest 3 per child. Did I just do int max? Whatever. While R mid equals L plus R minus L 2. If valid, we're gonna pass in mid. Okay, so if it's valid, so ones would be valid, right? So 1 is always valid. So we're looking for the maximum. Right? So we're going up. -1. If it's not valid, we need to make it smaller. Okay. And now let's go ahead and write valid. So it's what? Candy per child. So if I guess 5 candy per pile or per child. Okay. Now, how would we want to deal with validating the candies per child to see if it's valid? So if I said I had 5 candies, and I said, is it valid to that I can have this like this? Obviously, yes. Okay, if I said I had 3 candies, 3 goes into 3 times. 3 goes into 4 once. 3 goes into 3 once. So we count them. Should I just go through the entire candies array? That would be of in log n, basically. So if I go int count equals 0, or int I equals 0, I have less than candy dot size. Count plus equals candy per child. So it would be 10 divided by 3. So it's the candies divided by candies per child, which will never be 0 because L is 1 to start. Right. If the count All right. So you have 3, 3, 3, 3, 3 is greater than K. K, return true. False. Right? Oh, semicolon. 4. Oh, I'm getting off by ones. If valid. Oh, my binary searches are always broken. Oh, wait. Hold on. If count is greater than or equal to K. Oh, wait. Same issue. Okay, so it has something to do with how I'm doing this. I don't think it's because of equal signs. Or it might be. Left is less than or equal to R. If they're the same... Okay. Integer overflow. That's why they have long for K, huh? All right. Wow, that's actually kind of slow. Okay, it was a Coco's eating banana question. Why can I never spot those right away? I don't get it. The second they said binary search, I'm like, oh, I know what it is. Wow, it's so slow though. Is it because of the range that I'm using? Or maybe my testing? I don't know. Okay. Well, that's my solution for the day. Thank you for joining in. If you guys want a good problem that's similar to this one, Coco's eating bananas is like the question for these kind of things. So go ahead and go check it out. I will talk to you next time. Have a wonderful night. Peace.